So, hello. In this section, we are going to discuss one problem, and that is from Hacker Earth. And the problem name is Monk and the Island. And this is from Hacker Earth. So, I have copied the problem statement, same problem statement in the OneNote. So, we will go to the OneNote and discuss the problem. So, here is the problem. In this section, monk is there, one monk is there who visit the land of islands, right? And there are total n islands numbered from 1 to n, and some of the pairs are connected to each other by bidirectional bridges. Means no, it is not a unidirectional, it is bidirectional. So by seeing that, we can see that it's a question of graph. And monk hits the cross this bridge. It requires a lot of effort. He's standing at island 1. Suppose the source node, the root node, is 1 and wants to reach the island n. Total number of island is n here only. So means the monk wants to reach from 1 to n with the shortest path. So it is basically, it is the question from that we can see that it is the question of single shortest path, because we are given the source and we have to find the shortest path from 1 to n to reach n, and the starting node is 1. So he had to shall have to cross, and he takes the optimal route. What are the input types? T test cases are there. First line, two space separated integers n and m. N is the number of vertices and m is the number of edges. Okay, and m lines means the number of edges line will contain all the edges for creating the adjacency list, denoting the bridge between x and y. And we had to print our answer in a new line for all the test cases for reaching the node from 1 to n, taking the optimal path. Okay, test cases are 10, 1 to 10, n 10 to the power 4, m 10 to the power 5. So by taking int we can do that. Now let's see the test cases. Suppose this is the test case. Two test cases are there. For the first test case, it is from here to here, and for the second test case is this here from here. Okay, so let's see the first test case. There are 3 vertices and 2 edges. The adjacency lists are 1 and 2. 1 is connected to 2 and 2 is connected to 3. This is for the first test case. Okay, so the source node will be this one and the destination node will be this one. Okay, we have to reach here only. So from source to destination, we apply single source shortest path using the BFS, right? So we will apply BFS here. So the dist vector will be there, one dist vector will be there, one visited vector will be there. Okay, and the adjacency list are, you can see the graph only. This is the adjacency list. We can depict the adjacency list by reversal. And what are else are the things? Distance visited. So first we will go to the source node and we will make this as the current node is 1, and we have to make q also, right? For BFS we use q also. So this is the edges, vertices, indices. 1, 2, 3 are the indices here. So first we will go to the source node. So from the main function, we will call the bfs1. From the main function, we will call bfs1. bfs1 we will call from the main function, and after that we will update the distance in the bfs function. We will use distance of node, that root node will be updated to 0, and we will visit that node and we will insert it in the queue. Okay, now the while loop will work till the queue is not empty. So while loop will work as one current variable we will take, and that current variable will store that node which we are traversing, its child, and that will come from the queue only. So we will come under the while loop till the queue is not empty, and we use the current by popping it from the queue. We pop it from the queue, then current equal to 1. Now we will traverse the child of 1. The child of 1 is 2. So we will update. If it is not visited, then we will visit that node. Initially all the visited will be 0. All the visited vector will be 0. If it is not visited, then we will visit that node first. We will update the distance from distance of parent plus 1. Distance of parent is 0, plus 1 is 1, and we will insert it inside the queue, right? So 2 will be inserted. Now there is no child of 1 now. Now again while loop will recur since the queue is not empty. Then again the current will updated by using queue dot front, and the current value will be 2, and we will pop this out. Now we will traverse the child of 2. Since the child of 2 is 3 and it is not visited, as we can see in the visited vector, so first we will visit it. After that we will update its distance with the distance of parent plus 1, and that distance of parent is 1 and plus 1 will be 2. So distance of 3 is 2, and we will push it inside the queue. So 3 will be pushed inside the queue. Now the 3 is visited. 1 is already visited as it was the root node. Now when again while loop will come, and we will current will be q dot front, it will be